Okay, can you see my screen? Is my screen visible?
Yes, sir.
Okay, okay. So in the last class, we studied about the difference between supercharger and turbocharger, and we had looked at what is turbo lag, even what is supercharger and turbocharger, the difference between those. Today we will look about a topic called hybrid cars. So I have told you as a homework this one. Anyway, I will explain it. So basically, a hybrid electric car is a electric car itself, but it also uses IC engine, that is our conventional engine for working. Okay, so you can see here the engine is provided here, and there is a battery pack provided near the fuel tank. So you can see here the fuel tank is provided here and the battery pack is provided here, and it is connected by means of a IC engine. Okay, this is one of the type of a hybrid car which we will be studying later on. Then you can see it is written here, hybrid electric cars are powered by an internal combustion engine in combination with one or more electric motors that use energy stored in batteries. So what happens is that in an engine, we get rotational motion, which is then transmitted to the, here it is transmitted to the rear wheel. Okay. Instead of that, there is a component present in the engine, in the vehicle known as alternator. So what is the purpose of alternator? Alternator charges the battery that is present in the vehicle. So in a vehicle, in an automobile vehicle, there is a battery that is 12-volt battery is lead acid battery is provided in the vehicle for various purposes, such as electrical instruments on board, sensors, working of the ECU, then spark plug in the case of a petrol engine, uh, then rear and front lights, so on. So many functions are there for electrical purposes, and these powers are generated from the battery. Okay, just a 12-volt battery. From a 12-volt battery, such and such power is drawn. So since it is a small battery, okay, 12-volt is nothing but small. It produces only a small amount of power, and it can be easily drained away. Okay, after a few function of the lights and such, so and so on, the battery can be drained away. So how to prevent this? Okay, for that purpose, we are using a component known as alternator. So what does an alternator do? Alternator functions as a generator. So what is the function of a generator? Generator provides electricity by a mechanical motion. So how is the mechanical motion given? So we will be filling fuel into a chamber in the fuel tank of the generator, and from the fuel tank, it is an engine that is given there, and it runs. Okay, it is coupled with the motor, and once it runs, it generates electricity at its end. Okay, a mechanical load is provided and we get an electrical power. That is what is done in a generator. In the same way, in an alternator, the mechanical power is provided by the engine. So where in the engine exactly? It is there at the propeller shaft. So from the engine there is something called a propeller shaft, which is not shown here. It will come through the center itself. This is an electric drive, while in the case of a normal conventional drive, a propeller shaft will come here, and there is something called a differential that will be present at the rear wheels, and power will be splitted up appropriately for two wheels. So that is how it is done. So before the propeller shaft, there is this component called alternator, which has, since the propeller shaft is a rod that rotates, okay, since it rotates, that mechanical power is also utilized, that rotation is also utilized by a shaft that is present inside the alternator, which provides the mechanical load required for the alternator. This mechanical motion then induces a current in the alternator, which is then transmitted to the battery, and the battery gets charged up. Okay, that is how in a vehicle the battery is being charged up and used for day by day processes. Okay. In the case of a hybrid car, we are using a motor that is shown here. Okay, there is a here there is a motor here, electric traction motor, and a battery auxiliary is provided here. Also, a traction battery is provided here. Okay, the drive we will be giving are in three ways, which we'll be studying later on, and it uses, the hybrid vehicle uses a motor, one motor which will be coupled to any of the wheels. Okay, here it is front wheel, you can see it is coupled to the front wheel. So from the battery, power is supplied to the motor and the vehicle is started, vehicle is moved by means of a single motor. So the single motor is provided in one shaft itself. It is provided in one shaft itself, and the rotation of the motor causes the vehicle to move forward. So when do we need this electrical system? This electrical system is used during the starting condition. Starting condition, initially, for a conventional vehicle, we have to provide a rich mixture. So what is a rich mixture? I have explained it before. Rich mixture is the mixture in which the fuel amount is much higher, okay, than the air particles. That is, it is above the stoichiometric ratio. I have explained about stoichiometric ratio. So it is above the stoichiometric ratio. The fuel particles are more than the normal rate. So such a mixture is known as rich mixture. And in a rich mixture, we have the fuel economy will be much less. So you are supplying more fuel for the vehicle to move from rest, that is the first gear condition, even at the second gear condition. When it is coming into third, fourth, and fifth gears, the vehicle is smooth. So it requires only less power. Okay, since the vehicle is moving. So for that purpose, so we are looking at fuel economy, and fuel economy is less during the starting conditions. So at the starting conditions, if you provide an electric drive, such as a motor, then we will get high torque, and even we can reduce the fuel or completely neglect the fuel for that starting conditions. Okay, that is how a hybrid car works. So we use a motor that will be engaged during the first part of the vehicle operations, that is the starting from rest, then moving to a sufficient speed. After that, the engine side takes over. The engine side takes over and the vehicle is propelled forward. Okay. Another situation where in which we can reduce fuel is during idling condition. So in an idling condition, I have explained it before, specifically during signal points or when you are stopping the vehicle but not switching off the engine. In such a condition, the fuel is still going into the cylinder. Okay, we are losing fuel. So electrical systems also is switched on during engine operations. So for that electrical functions such as the lights, media players, etc., for these purposes, the electrical system takes over and handles it during idling conditions, switching off the engine itself. But the vehicle is not stopped since the electrical system is still running. Okay, this is how fuel economy is preserved, and these technologies are used nowadays to reduce the fuel consumption during these times. So that is why hybrid cars are becoming popular right now. You can see this results in gasoline burned and therefore better fuel economy. Okay. So you can see how here also it is in a front wheel drive. So there is a battery pack here, and from the battery pack the drive is provided to a motor here. The motor is present here at the wheels, and the motor takes over by the power supplied by the battery. For charging of the battery, we again use gasoline engine itself. So during other operations, that is at high speeds and all, the engine side takes over for transmission. Once it takes over, it charges up the battery by means of an alternator and another technique known as regenerative braking. So I'll explain what is the regenerative braking. So regenerative braking is nothing but using the braking system in the vehicle for generating power. So what is braking? We usually use a brake pad, that is a friction material provided at the wheel hub. While applying the brake, this friction material comes into contact with the wheel hub. So the wheel will be provided there. This friction material is provided pasted here. Okay, it is pasted on this side of the gear shown here, and once it engages into the wheel, the friction material, due to its friction, generates the friction and stops the wheel or reduces the speed. Okay, and finally brings it into rest. So that is how a friction material works. So during that process, the brake pads are heated up and we are losing the power. That is the power we are getting at the propeller shaft and from the differential and all. This power transmitted at the wheel is lost as heat during the friction. Okay, this can be utilized. If this is utilized for generating power, then that technology is known as regenerative braking. So what happens is that once the brake gets engaged, you can see it is in the shape of a gear, and what happens is that once it engages, it will rotate this part component shown here. Okay, this component is connected to a motor. Okay, the motor that runs the wheels. So what happens is that the rotation of the motor is reversed. So motor rotates in one direction to provide us. So what is the function of a motor? Motor obtains electrical power and transmits it into mechanical power. That is what a motor does. So the motor here is rotated in the opposite direction. So what will happen? Motor will act as a generator. It will act as a generator. So what we will do? We are cutting off the battery supply during braking, and due to the reverse direction motion of the motor receives a mechanical power. So mechanical power in the sense of a rotation of its shaft. So the rotation is in the opposite direction. Due to this rotation, current is generated in the motor. This is then supplied back to the battery. So this is how the battery is charged in a regenerative braking principle. Okay, so the both two methods are used for charging of the battery. One is regenerative braking, which I have been explaining it now, and another one is by means of an alternator itself, by the engine working. So the engine works, and the rotation of the engine is transferred to the alternator. The alternator converts the power and then sends it back to the um, battery itself. So the battery is present here as traction battery for motor, and the auxiliary battery, that is the normal 12-volt battery that is provided here. So this battery can be a higher than 12-volt battery Normally 12 volt battery is another 12 volt battery is added, but it can also be higher battery because it has to give significant power to the motor that is shown here. Okay, it can be used one motor or two motors. Mostly one motors are used and it is coupled in a shaft. So one shaft will be running through and there will be one motor only. One motor is there and a single shaft runs through the wheels to turn the wheel. So you can see how the regenerative braking happens here. So once the vehicle is brought to rest, it will act as a generator mode. This is a drive mode. So battery is applying power. Once it brakes, the reverse flow is occurring and it is transferring it to the battery. So this is the battery pack and it is then transferring here. Okay, you can see how it is transferred back to the so here there is acceleration and brake. This is the braking condition and the braking condition generator mode is selected. So you can see the generator mode and drive part which is the acceleration mode. Okay. Next, in another point is shown here. In regenerative braking, where in conventional braking, where excess kinetic energy is converted to unwanted and wasted heat due to friction in brakes or with dynamic brakes, energy is recovered by using electric motors as generators. So electric motor act as generated for functioning as providing power to the battery. This improves the overall efficiency of the vehicle and it can extend the life of the braking system. So the braking system has a brake and the brake pad are eventually worn out. So it is being, due to friction, it is being worn out very quickly and due to that we had to replace it frequently. So by this method, the braking system mechanical parts life is increased due to we are providing we are not completely stopping it, rather than we are providing that power to a another shaft, okay, to another shaft that is present in the motor and the rotation is reversed so that the motor can generate power back into the battery. Okay, so that is what is happening in regenerative braking. So here you can see the hybrid car working. So the battery is here, there is an engine here, this is the motor, and from the battery, this is the charging mechanism that is shown here. So this is through the engine it is charged, the motor, from the motor the power is transferred to the battery, while the power from the motor is transferred like this. You can see it is coupled in a single shaft itself. It can be normally it is present here itself on the shaft itself or the axle, it is present here, and the battery is charged through regenerative braking and by internal combustion engine. So the engine provides the power and also from the wheels by through means of braking system. So we can also when two motors are present, it will be, one more motor will be present here. So significantly, again the power can be transmitted from this motor to the battery. So this is how a hybrid car works. So you can see here also. So this arrow shows how the power generated at the brakes is transmitted. So the vehicle is not stopping, but it is showing how it is charged. So it is through this shaft itself. The motor is provided here. You can see a motor here, and from the motor, rotational power is given. From the battery, it is connected, and the rotational power is given. There is an engine present here, which is not being shown. Only the electrical side is being shown here, and significantly we will get the rotation. So the battery pack is much higher here than that of a than that of a 12-volt battery. Next, so the vehicle here is the Lexus UX edition, and this is also a hybrid vehicle that is most commonly used. Next, we will look at the types of hybrid vehicles. So there are basically three types of hybrid vehicles: parallel hybrid, series hybrid, plug-in hybrid. What is parallel hybrid? In this design, the electric motor or motors and gasoline engine are connected in a common transmission that blends the two powers. So most commonly that we have seen in this system and all, it uses both engine and electrical side. Okay, so during low power conditions we use electrical part, wherein the vehicle is started at rest, providing high torque, and we will get more power and less noise during that operation. And once the engine takes over during higher speeds, the electrical part is shut down and it begins charging by means of the alternator and regenerative braking mechanism. So such a mechanism or such a type of hybrid is known as a parallel hybrid. Okay, one we have discussed before. So the transmission can be either automatic or manual or continuously variable transmission, which is CVT. Okay, that is automatic in the means of automatic drives that we have seen today. Manual drives in the means of shifting the gear manually, and then continuously variable transmission. It's also an automatic, most commonly used automatic system nowadays. Okay, that is a CVT transmission. And commonly seen parallel hybrids are Toyota Prius and Chevrolet Volt. So this is a Toyota Prius, which is shown in the background, and another one is the Lexus UX. This is also a parallel hybrid. So these both are parallel hybrid. Um, Transmission type and the size of gasoline engine are the main factors that determine how a parallel hybrid will accelerate, sound, and feel. So that is how that are the main factors. So the transmission type, that means a real wheel drive, CVT, automatic, manual. Depending upon that, we can say how the parallel hybrid will accelerate. Accelerate means move forward or pick up speed very fastly. Then sound in the sense of vibration and significant sound that is provided by the engine. And then the feel is nothing but the smooth movement of the vehicle without any jerking or unwanted swerving and all. Okay, so these are three conditions, and the factors are transmission type and the size of gasoline engine. So once the engine size is high, more bigger, then more vibration can be occurred, and we will get more sound rather when compared with a smaller engine. So significantly smaller engines are used as we are getting sufficient power at high speeds by means of the small engine itself, while also due to the electrical system provided in the engine. So you can see how the parallel hybrid is arranged here. So the motor is coupled with the mechanical coupling, and the drive is given to the wheels here. This is the IC engine, which is also coupled, but it is parallel. You can see how it is collected in parallel, and it will take also over the mechanical coupling. Okay, once the speed reaches higher, this part is cut off and this takes over and it is charged up. Okay, fuel tank is also provided. Next is the series hybrid. In a series hybrid, you can see the electric motor or motors provide all the thrust, and there is never a physical mechanical connection between the engine and the wheels. So an engine is also present and an electric motor is present. So what is the purpose of the engine? The gasoline engine is just there to recharge the battery. The battery is only being recharged. For recharging the battery, the engine is provided in a series hybrid. So it is completely mostly an electric car if the engine is removed. But the engine is present only there to recharge the battery, because the battery has battery will drain faster due to a smaller battery pack, and also due to heavy power requirements for running the vehicle. So for that purpose, we had to recharge the battery, and for recharging the battery we use a gasoline engine. And using a series hybrid, it is more indicative of an electric car. So it provides smoother and powerful acceleration. So giving a smoother and powerful acceleration means the vehicle reaches top speeds at smaller time intervals, and it is done smoother also. So you can't differentiate any jerking or any noise or any lag. It is happening at a faster pace. So that is what when using a series hybrid electric vehicle. So common examples are BMW i3, which is shown here. This is the BMW i3 here. And another is the Nissan Note E12. This is also a hybrid car. Mostly nowadays, hybrid cars are used mostly, but only electrical systems are changed. We are not using any motors and all, but significant electrical components are used in engines to improve performance. But in hybrid cars, we are using a motor also to take over the drive itself. So common examples are BMW i3 and Nissan Note E12. And due to completely electrical system taking over the transmission and the movement of the vehicle, there is typically less vibration of the gasoline engine that is present inside the vehicle. So the gasoline engine will be smaller engines than compared with parallel hybrids, because it is there only to provide power for the battery, to recharge the battery. So significantly low gasoline engines are required, and a powerful alternator is present that generates sufficient power for recharging the battery. So it is depending upon how the battery is used, engines are fitted. So how much it is drained, that much must be recharged, and for recharging purposes, significant engines are used. So you can see how in a series it happens. So the engine is separate here. Okay, the engine is connected only to the inverter, not to the motor. It is connected to the inverter, and from the inverter it charges up the battery. So this is the engine connection. While you can see in the motor, from the battery it goes to the inverter, which increases the power and supplies it to the motor, wherein it drives. There is the mechanical coupling that is shown here, a gear drive, which is then connected to the front wheel. You can see the front wheel here, the drive wheels, and the vehicle is propelled forward. The last type is plug-in hybrid. So in a plug-in hybrid, it is completely an electric vehicle. Okay, you have the engine and also the motor, but you have to charge the battery by means of household electricity. You have to plug in. Okay, there is a fuel tank also, and there is a battery point also. So it is not a recharging by means of it will recharge, but it will only provide less power for the battery, because this is used for both type of transmission. So when you need it in all electric mode, you can use it for all electric modes. That is up to 15 to 55 miles. It is an all electric experience. So you can drive it completely at electric mode. And once that is drained up, you can use the engine fuel tank side. Okay, so there is always an alternative here. In a plug-in hybrid, there is always an alternative. So once one part of the engine side, or one part of the movement system empties up, you can use the other one. So for that purpose only, we are using plug-in hybrids. So for initial starting and all, you can use electric system, and then after completion or the draining up the battery, we can use the next part. So the recharging part is most efficiently done by means of an household electricity. So when we plug it in overnight, you will get it charged, and you can use it for about 15 to 55 miles depending upon the model. Okay. A common example are Chrysler Pacifica. You can see here that is provided at the back. Okay. Okay, I will wind up the class today. Next, I will take the attendance.